Inside Science.
By far and away, the biggest story this month has been the outbreak of coronavirus, and the news is moving fast. As we recorded this video, the virus had infected over 80,000 people globally and killed 2,700. The government of Wuhan in China officially announced it was treating people for coronavirus on New Year's Eve 2019. On the 11th of January, they reported the first death from the virus. By January the 21st, coronavirus had reached Japan, Korea and the US, and on the 30th of January, the World Health Organization declared a global health emergency. 4 days later, researchers took a huge step towards combating it. They sequenced the new virus's genome. At just under 30,000 base pairs long, it's 100,000 times smaller than our genome, and is 89% similar to its closest viral relatives, those that caused the SARS pandemic in 2003. Coronaviruses get their name from the spiky proteins spread across their surface that look a little bit like the spikes on a crown. One of these protein spikes is essential for the function of the novel coronavirus, the S protein. And the S protein binds to a receptor on the host cell, fusing the viral membrane with the hosts and allowing the virus to inject its DNA. On February the 20th, scientists from the University of Texas published the molecular structure of this S protein spike. Now, knowing what the spike looks like in such detail will help researchers design treatments for the disease, such as small molecules which could disable the action of the S protein. Now, such treatments will take time to make, but an experimental vaccine has already been produced for clinical trials by a US company, and groups across China have begun their own clinical trials on other possible therapies, including antiretroviral drugs, antimalarials, and even testing the blood of recent disease survivors for potentially useful antibodies. Scientists have also been trying to work out where the virus has come from, and this is by no means definitively established, but the first cases seemed to stem from a seafood and live animal market in the city of Wuhan in China. The virus may have originally jumped from an animal there to humans, and a prime suspect is bats. They carry coronaviruses whose genes have been found to be 96% similar to the human coronavirus. However, since the bat population hibernates in December, the virus would probably have travelled through another animal as an intermediate host, such as the pangolin. Now, pangolin scales are a popular ingredient in some Chinese medicines, and an as yet unpeer-reviewed study found that coronaviruses in some pangolins displayed similar proteins to those of the human disease. All in all, it's been a worrying few weeks for the scientific and the medical community, and for the people who've been infected with the virus or affected by the quarantines in China and a growing number of other places. The latest estimates show that the virus is killing about 2.5% of those who contract it. Now, that rate is much higher than the seasonal flu, but it's also far lower than the 15% death rate for people who contracted the SARS virus in 2003. And the Ebola outbreak between 2013 and 2016 killed 50% of those who caught it. The World Health Organization has not yet designated the coronavirus as a pandemic. And while teams work to contain and to treat the coronavirus, help combating bacterial infections arrived this month from a new and unexpected source: artificial intelligence. Researchers from MIT trained a neural network to recognize molecules that might make good antibiotics. The researchers showed the algorithm 2,335 different molecular structures, along with data on how good each molecule was at killing bacteria. The AI learnt which structures would make good antibiotics, then combed massive libraries of potential molecules to find ones that might work. The algorithm identified 9 potential new antibiotics, all built differently to ones that we currently have. One of these, halicin, was even shown to be effective against Acinetobacter baumannii, one of a number of pan-resistant bacteria for which we desperately need new antibiotics. And you can read more about that in this Inside Science article. But let me leave you on something completely different: the surface of the sun. A new telescope 10,000 feet up in the mountains of Hawaii has taken the most detailed images ever of the sun's surface. Now, in it you can see the turbulent plasma that covers the sun. Each of those blobs is around the size of Texas. Hot plasma rises in the bright centre and cools and sinks on those dark lines. And to take these pictures, the telescope's 13-foot mirror has to be constantly cooled, along with the rest of the telescope, to protect it from the sun's incredible power. And that's it from me this month. Goodbye.
Inside Science. If you enjoyed this edition, follow us on the web and social media. Powered by the American Institute of Physics and a coalition of underwriters.